A second technique that may come up is a factoring technique whenever we have four terms. This method is called grouping. And uh, what we want to do though, if you go back to my first video, we always want to start with trying to factor out the GCF. So if you look at the numbers again, all four of these numbers, all four of these terms have a 3 in common. And if you look at the variables, the fourth term does not have a variable in it, so we can't factor a variable out. So my GCF for this term, for this problem, is just a 3. So if I factor a 3 out of all four of those terms, what I have left is t to the third plus 5t squared, because that'll make 15, minus 2t minus 10. I almost forgot to do that earlier, but that's what you always need to do first. Don't forget that. You always try to factor the GCF out. Okay, so we continue to carry that GCF, but what we're doing now is we're pairing off the first two and the last two and trying to factor a greatest common factor out of each pair. So what we've got from the first pair that you see, so we're doing another GCF just with these first two terms. You see the first two terms, t cubed and 5t squared, have a t squared in common. So I'm going to bracket that out and do a separate problem here, and t squared is my GCF of the first two terms. And that gives me t for t to the third plus 5. And you see how that gives me, if I multiply that out, that would give me t to the third plus 5t squared. Okay, now if I move on to my sign is minus here, so I bring that out. And the 2t and the 10, the number that's the GCF for those two would be a 2, so I factor a 2 out, and that gives me t for minus 2t. But remember, you factor the negative 2 out, so I should do a plus 5 here to get my negative 2t minus 10. So that's my first step. Now, if I move, I've got to continue this problem. So if I move to finish this problem, so what you're seeing now is inside this larger parenthesis here, you're seeing the t plus 5 come up for both terms. So this is kind of weird, but you can also factor out an expression. So since they both have a t plus 5 in them, I'm going to factor the t plus 5 out. And if I factor the t plus 5 out of my first set, so I take that out, that leaves me with t squared. And if I factor a t plus 5 out of my second set, that leaves me with a minus 2. And so I have factored that now because everything is multiplied. I'm doing 3 times t plus 5 times t squared minus 2, and I'm done with my problem. So for my second example, I have 9q to the third plus 6q squared plus 15q plus 10. Again, you're seeing four terms, but if I look at each term, there's no number that goes into 9, 6, 15, and 10, and they don't all have q's in them. So unlike the first problem, I don't have a GCF for all four of them. So what I now do is I look at pairs. So the first two and the last two. Okay, so if I look at those in terms of just being pairs, what I've got is a GCF between 9 and 6 of 3, and my lowest power of q's is q squared. So that's my GCF of my first two terms. And if I factor a 3q squared out, I have a 3q left. That'll give me the 9q to the third power. My plus sign from here. And if I factor a 3q squared out of 6q squared, I'm left with a 2. Moving on to my second two terms, I see my plus sign here, so I put my plus sign down. And my 15 and my 10 have a 5 in common, which leaves me with a q plus 2 left to give me that polynomial. I'm sorry, a 3q plus 2. I almost forgot that because I've got to get 15q and 10. So it should have a 3 in there, you guys. So what you see happening now is that I do have the expression 3q plus 2 that is common to both terms, so I have to factor that out, which I'll do now. So I factor out the 3q plus 2, and that leaves me from the first term with the 3q squared, my plus sign here, and from the second term with my 5, so plus 5. And you see I've got everything factored because I've got 3q plus 2 multiplied by 3q squared plus 5. That means I'm done. Everything's reduced. So let me move on to my last example here. Okay, for my last example for grouping, again, if you look at all 4 terms, 3x squared, xy, 6x, and 2y, there's no number they all have in common, and all of them do not have an x, nor do all of them have a y in them. So there's no GCF for all 4 of those terms. So I will look at 2 of them together and try to do the GCF for each 2. For the first 2, they have an x in common, and that's all. And if I factor an x out from the first 2, I am left with 3x minus y. Okay, now go to my sign here in the middle, so it's a minus, so I'll try the minus. My last 2 terms, 6x and 2y, have a 2 in common, and that's all. If I factor a 2 out, remember it's a negative 2, I have left a 3x, and because that's a negative 2 and I need to get a positive 2y, I'm going to put another negative down here, and I have left a y, and that does give me my minus 6x plus 2y. Again, what you're noticing is that the 3x minus y is common to both terms, so I will factor that out, 3x minus y. And what I have left then is the x from the first term, my minus sign, and my 2 from the second term. And that is what is called factored form because I am multiplying 3x minus y times x minus 2. And that's it. That's factoring by grouping.